we have today 6 presentations with focus on chemistry. And these are quite interesting because we have 2 big players from Norway with us. And Beyonder. It doesn't mean that we don't have a good place in Germany. We have from Germany. They're starting in the beginning with, I think, Robert, you're doing it, with Mauro, and he's talking about 4 minutes on sustainable European batteries. You have 4 minutes to talk, and there will be, in the end, a 4-minute discussion. Okay, so floor yours.
Well, thank you very much. Yeah, great to talk to so many experts around Europe and the world. And obviously, you all recognized what happened this year in Norway. So we had 2 really big milestones. One was that we almost reached 90% in pure BEV vehicles and new registrations, but also during the year in the, let's say, registered field, electric cars, full electric cars for the first time overtook petrol cars, and diesel is just the time to come. So everything's set for a sustainable future. Nevertheless, there's one thing not yet so nice about that, because without having a sustainable battery, whatever we can reduce in lifetime CO2 reduction is limited. Just an example with a classical passenger EV. So the cells alone in an 80 kilowatt hour NMC pack will have a rucksack, you could call it like this, of more than 6.5 tons of CO2 emissions. So clearly not the best start into a life, you could say. So what do we offer? What do we make different? We make batteries more sustainable. How do we do that? 3 approaches. The first one, we are using 100% hydropower already today for the production we use. Secondly, we are recycling materials. For example, we capture all the NMP you use as a solvent, recycle that, reintroduce it to the process. And third one, we're working on improving the materials of existing chemistries, but also of new chemistries. And what can you achieve by that? What do we achieve by that? So, for example, looking at LFP, graphite standard chemistry, where currently an average battery you can buy on the market has a CO2 footprint of 91 grams per watt hour. Our product we are introducing this year, roughly in 4 months, will already have that reduced by 33%. By the end of the decade, and the route is set, we will be down to 21 grams, reduction of 77% at the beginning of the life. LMNOx, which is a very proprietary chemistry we are introducing in 2 years. The typical competitors will be LTO, as an example. We can reduce the life begin emissions by more than 70% in the 2nd generation. And our greenest animal, you could call it like this, is LNMOC, a graphite chemistry, high voltage chemistry that can replace NMC in energy density and also in power and other aspects. And using this one, we can bring down the CO2 reductions at the beginning of the life by almost 90%. The result is, instead of having 6.5 tons of CO2 emissions at the beginning of life for a battery pack, it's less than a ton. And you can also use a lot of these chemistries for BESS. So it's similar. Our target is to bring down CO2 emissions substantially and allow for a green life of a battery pack. In case you're interested, you want to reach out, here are some contact options. Follow us on LinkedIn, give me an email, or send us an email at sales@morrowbatteries.com. Yeah, now yes. Open questions.
Yes, thank you. I think it was perfect timing. One quick thing. Can you take your LinkedIn and copy it in the chat?
I will do it.
Because the link, so that everybody knows, the link, if you want to share something like an email address, please share your LinkedIn link, because you can click on the link. You can't click and you can't copy emails out of chats. So please use your LinkedIn link. So any questions? If not, I have a question. What is Morrow doing? What is Morrow doing, and how active is Morrow in Germany?
So basically 2 things are very strong in Germany. One are obviously customers. So we have a bunch of companies we're talking to, or we have currently evaluating our sample batteries in Germany in different industries. A second, more than or roughly 50% of a sales team like myself are sitting in Germany, because by that we cover the Central European market. The other half is sitting in Grimstad and in Oslo and covering the Scandinavian market, but we're working very closely together. So activities in Germany, obviously selling and having customers we support.
Okay, is there any intention to come and build plants here?
Too early to think about. We're a Norwegian company. We're really conservative, so we have a very dedicated step-by-step growth process that is less aggressive than with others. You could call it conservatively ambitious. So we're shooting very strongly on not overselling and delivering what we promise, and then grow by that. We didn't plan yet any plants outside of Norway. Nevertheless, on the long run, yeah, we have strong ambitions. So that is likely to happen.
Okay. Any questions to Robert?
Yes. Yeah. I would like to ask, can you say what level of production are you at the moment? So in terms of serial production.
Yeah. So the first product we will bring to the market is our LFP cell. And we're currently in the process of commissioning the series line. Mm-hmm. So where do we start? Basically, the first production step we have is mixing of the slurry. So we do everything starting basically from the mixing, coating, drying, calendering, notching. Stacking is already commissioned. Stacking we're currently optimizing. The next steps will be then obviously the assembly of the cell. And the series product will be ready in July, but we will deliver large quantities of C samples already starting in May. But the certification will not be finished before July. So we're basically in the last steps of commissioning and then optimizing.
Okay, that's a question from Christoph. It's in chat already, but Christoph, please ask yourself.
Thank you. Short question. When in your optimization plan are you planning to introduce dry coating? Because you still said you were conventionally drying the slurry.
Yes, that's also not planned, to be really clear about that. So our future chemistries, also LMNOC, for example, can work with a solvent that's called water on both sides of the electrodes, cathode, anode, which gives us already a big advantage. But the current plan is to stick with conventional manufacturing production, let's say, processes, but at the highest level. We all know that, let's say, there are advantages of getting dry coating, for example, and other things potentially there, but it's associated with a lot of rollout risks. And as a company, we're currently too small, and we focus on, let's say, reducing risk. Nevertheless, our drying process, for example, is not using gas or anything like that anymore for heating. Our entire drying process is using hydropower energy, green energy. Basically, it's electricity. So we managed to bring all the processes to a level where we can work with electricity. And our biggest owner, 𝗕ₐ, is the biggest hydro energy provider in Norway. So we have 100% hydro already in our plants.
Okay, thank you for this longer answer. So there's one answer on the chat from Enrico. Silicon-based AAMs, are you looking into that? Please answer them directly in the chat.
Yes,
you haven't shared your LinkedIn link.
I will do it directly after. Yeah.
You will do it after. Very good. So because we are coming now to the second presentation, why we are, I don't know, have looked here at Morrow. We have reached the 200 limit here of people participating, and number 200 was Florian Engel. He was a guy who presented here as well. Number 200 was Florian Engel. He presented here in April in Battery Innovations, and so therefore it was a pleasure to see him. And I had a promise. I wanted to share the link to the European Chemistry Partnering event. This one is in Frankfurt. So we are presenting the next time from the European Chemistry Partnering event. And if you want to see us live on the 12th of February, we are there. But there is, I think the more interesting session is really also the online one, which is a speed dating event. Have a look into that. There is a link in there, 9th ECP something. It gives you a 20% discount because that's something what we negotiate for them because we are there. And so if you're interested coming there, or if you're interested in only the online session, go there. And that's the stuff with the European Chemistry Partnering. And there's also now the link from Robert in the chat. And we're coming now to the second one. It's about the Japanese market a little bit. So it comes from Tanya. Tanya, you're ready? Because it's about access to Japanese know-how on the market. And I think that's the Japanese companies are quite interesting. So we have big automotive players, but we have also big battery players. And Tanya, the floor is yours. You have 4 minutes. And 4 minutes Q&A afterwards. Thank you.
Good. Yeah, thank you very much. Good afternoon or good evening. It depends where you are in the world. So thank you so much for TraWeBa. My name is Tanya Zyslian. Thanks for this event and all your participation. I'd like to introduce you today the Japanese company GlobalTech, who is a specialist in evaluating batteries dedicated for electric vehicle as well for BESS. Yeah, as Robert said before, rechargeable batteries and reduction of CO2 is an international topic, so needless to tell all of you. And even it is a global interest, the main players are the majority, I don't say still, but the majority in Asia, including Japan, as one of the pioneers in rechargeable battery technologies. In Europe, we have the challenge, especially the car industry, I would say, to catch up producing batteries. But I worry without consulting with experienced partners, it will be quite difficult. On the other side, if you like to enter with your new materials or processes, innovations to the Japanese market, again, it is helpful to have a local partner. So I just recognized I didn't move on with the presentation. I'm sorry for that. So in the last 20 years, we at GlobalTech built a wide network in the Japanese battery society. So we are working with a well-known battery as well car OEMs. So some of you might be interested, who are they? But I'm sorry to say, due to our company policy, I can't really mention our client names, but you can be sure you know some of them because they are quite large. The company structure and especially our engineers are all coming from the battery industry. So our managing director, for example, was for centuries the head of a giant Japanese battery OEM. So we know how difficult it is or how challenging it is to develop and produce stable, performing, and safe batteries with a good yield. So if you have innovations on batteries and or submaterials and like to enter the Japanese market, we can test the effectiveness of your solution within our 2 large laboratories we have in Japan. So fact that GlobalTech is the market leader in Japan for evaluating batteries, our report might be well recognized document for your Japanese clients. On the other side, for example, if you assemble cells to battery packs and using cells from Asian manufacturers, we can as well test the cells in our laboratories in Japan, which is much more closer than bring all the cells from Asia towards to Europe for testing them. And finally, if you like to become or on the way to become a new battery manufacturer, we can as well support you during your development milestones, as we do with all our Japanese clients using our deep know-how and experiences. So we are here to support you developing your battery product and helping to bring evidences to make your solutions attractive and convincing to the Japanese market, but also worldwide, the markets interested in batteries. So please contact me at GTS Energy Solution in Düsseldorf, which is the subsidiary of GlobalTech outside of Japan. And let's discuss how we can support you. Thank you very much.
Yes, thank you. Very nice person. You should have moved your presentation. I think it's really important. But I think the key message came through. If somebody's out there who wants to have access to the Japanese markets, talk to Tanya. I think that's an easy message. And you guys also looking to come to Germany or to Europe, correct? In order for manufacturing.
Exactly. So we built this subsidiary in the beginning of last year, and we are now talking with different partners on the equipment side, as well on the location side, where we can build our first laboratory outside of Japan. So it might be within Germany or close to Germany. That is my aim. Yes.
Yes. So I think it's a message maybe to TraWeBa or the ACOD. Contact Tanya to get him close to Leipzig. Okay. Any questions to Tanya? No question. Okay. So you see, it was simply clear presentation. But if the point is, please share your LinkedIn link as well, so that the people know exactly how to contact you. And if I have access to my framework, I will do that too. That's currently we have a very unstable line here, but I think it's still a line, which is out of Tanzania, quite interesting. Okay, then we're coming to the next one. It's about mathematics. It's about microstructure. And we have from 𝗕𝘁𝘁𝗶𝗴𝗵𝘁 the point on, I think they changed the title slightly. The title was Microstructure, the key to battery manufacturing, but it's about mathematics in the end of the day. How can mathematics improve, battery and battery manufacturing and so on. So over to you. I think Stefan, senior, yes. Here we go.
Yes. Okay, can you hear me?
Yes.
Okay. So my name is Steffen Wörner. I'm at sales.
Please, one thing. Please go in presentation mode with your presentation so that we see the full screen. Would be great. I give you the extra seconds for this one.
Is it working now?
No, just go on the. Yeah, here we go. Looks good. Perfect. Thank you.
Now I killed it.
No, it works. We are seeing it. No, you couldn't.
So, do you see something?
Coming, yes. It's still the presentation. Here we go. Now it works.
Okay. So my name is Steffen Wörner. I'm in sales at Master Market, and I want to show you
how mathematics can revolutionize the battery development. And with us, you are able to use digital models for the development of your battery materials or separators, your anode or your cathode. We have highly efficient mathematical models to describe the materials in a digital way. You will receive the digital microstructure, what enables you to determine many physical properties, such as electrical conductivity, diffusion of ions, terminal conductivity, porosity, grain size, or porosity. If you connect these loose ends, you are ready to take on complex simulations. What does that mean to you? Monitoring your production process, for example, electrolyte filling, or improvement of the current battery materials and technologies, for example, the degradation simulation, or development of new battery materials, charging simulations. Currently, we have two ways to enter the world of digital material. The first is use your CT scan, FIBSEM scan, and 3D images, and we are able to import them and segment them and make a digital twin out of it and progress in GeoDict. The second way is you use our structure generator. Is based on our digital material database, and you can design your own material, generate your own material, design your own material, and use it then in GeoDict and develop the new materials for batteries, anodes, and all that, all the other components. We have 5 of 7 biggest players are using our software. And why does our clients use the software? Because we have the speed up time to market. We have save costs and resources. We explore behaviors of electrodes, develop efficiency electrodes of electrodes and cell design, and improve the battery performance and lifetime. And for that, we have a case study where we use GeoDict in the whole development process with running analysis, develop new materials, and simulate different stages of the material. Thank you. This was my presentation.
Okay, thank you very much. Any questions to Stefan? To use AI for calculations as well.
We are implementing some AI solutions. Yes.
Can you say a little bit more about it?
Sorry?
Can you say a little bit more about it? Can you elaborate a little bit?
Yeah. The software is very complex, and we have some areas where we use AI, where we use grids to train. If you have detailed questions, get in touch with me, please.
So I've pushed for this one. I've pushed Stefan's LinkedIn link into the chat, and therefore connect directly to him, because I think, especially artificial intelligence, things that artificial intelligence is not only large language models. I think that's the point. Okay, we have some other questions. How reliable is your data? How long does your company exist?
The company is a spin-off from Fraunhofer. The spin-off take place in 2009, and we have on every mathematical model, we have a validation phase to see that the physical data are the same as the mathematical data, and we can do that on single request or on standard request.
Yeah, there's a question also on sodium batteries, as well as is your data limited to FIB, lithium, NMR, and so on. So what with the materials?
No. We are able to simulate all materials, and the software brings a big database along with the software of around 400 materials where we have the properties and the physical data, and we also can create new materials with our structure generators.
Yeah. Okay, and the last question for you, does your simulate include membrane materials?
I can't answer that question. Please write it to me in the chat or on my email, please.
Yeah, it's in the chat. If you can, I think it was AP, whoever AP is, the anonymous AP. Please send it directly to Steffen that he can see that, or please connect directly to his LinkedIn link. Yeah. I will throw the LinkedIn one directly in the chat again so that everybody has that. Here we go. And so if you guys want to present yourself in battery innovations in Spotlight, please, I've put the list, the link already in the chat. Please use the link to apply there. It's called TraWeBa.de/𝗕𝘁𝘁𝗶𝗵𝘁. You will see a simple slide. You can select, you have to put your name in, logically your company, as well as check a date. We can't promise a date to be honest, but please use this one to find your way into this session here. We're coming now to the second big player in the Norway, and this one is Beyonder. And it's about yes, I would say high power, great life cycles in batteries, and the way to this one. And I think we have Yasmin with us. Yasmin,
yes.
You have
Thank
4
you.
Minutes.
Thank you very much for the invitation and possibility to present Beyonder at this webinar. My name is Yasmin 𝗕𝘁𝘁𝗃. I work as a VP sales in Beyonder, and today I would like just to drag you through Beyonder offerings at the product level, where our focus is high power and long cycle life battery technology. Just to give you an idea, we all know about the power and energy spectrum, where we have supercapacitor on the left-hand side offering quite excellent power properties. You have the energy density battery technology, which has evolved quite good, driven by EV market last years. Excellent technology, but very good at energy density, but cycle life and power properties not that good. So Beyonder was established in 2016 with an aim to electrify and help electrify the industry, industrial application, to reduce the carbon emissions. In that way, we saw quickly that we need diversity in the battery technology. So our focus was to bridge the gap between these two excellent technologies and develop battery cell technology that is combining these in a way and offer very good power property in addition to good energy density, and still maintain the cycle life. So here, just given with a few examples where the kind of technology would fit in, this is just a few of them, but typically in maritime industry, heavy duty, and the power backup applications. So over the last 8 years, we've developed the technology, and our first commercial product now is released, produced at large scale, giga scale. We have chosen a business model where we outsource our technology and produce it at large-scale production facilities until we are capable of building that infrastructure in Norway and Europe. So for now, we've secured commercial production, and this product is fully certified and tested and available for customer orders. What you can see clearly is that it is a battery cell, which has 120 watt-hours per kg, but the power properties from a single kilogram of this cell is 3.3 kilowatt, which is enormous power, and in addition to quite excellent cycle life. So for those that are more interested in the product itself, how the cycle lives are, what you can see in the left-hand side is the cycle life graph, where we have continuous cycling of our products. So fully charge and discharge within 12 minutes, 0 to 100%, only 2-minute rest time. And we can do it over more than 10,000 times, allowing the remaining capacity on cell to be 70%. If you reduce your C rates and apply and allow for even longer charge time and discharge than 12 minutes, you could actually increase the lifetime to up to 15 and 20,000 cycles. So it provides you flexibility to use this cell as a traditional 1-hour cell, or you could actually use it and be fully charged from 0 to 80% in 5 minutes. And what is also interesting to see is the thermal properties of the cell, where heat generation at constant cycling over several thousand cycles is very low. And if you want to compare this technology to something that is familiar out there, the closest performance-wise would be LTO technology, for those that are familiar with that. Given the fact that this is an LFP chemistry, so cost-wise, this would be a very attractive solution over an LTO. And the performance-wise, with the power capabilities and the cycle life, it has gained good traction within mobility market, where 12 and 48 volt batteries are coming up as good potential applications for this. So taking it from cell, we are also working with mobility modules and tailor-made for heavy-duty applications, buses, trams, rails, and so on. But we're also working on 12 and 48 volt modules with our partners, and stationary storage. So this is really to help speed up the product into the markets. I think I maybe spent my 4 minutes, but this is really what I wanted to share with you, the purpose. And if in case you're interested to hear more about Beyonder or these products in general and how we actually do this, please reach out and we'll gladly set up a call or whatever is needed to yeah. I think you are muted.
Here we go. I muted myself. I just one quick question. What is your call to action here to the audience?
Well, I think what it is, it's actually that we are going commercial. So we are looking for customers, partners where we can develop further and offer this product to our customers and help them electrify their application.
May I ask, at what technical level are you at the moment?
Sorry, I didn't get the...
At what technical readiness level are you at the moment?
Oh, we've produced C samples, so we are fully commercial for the cell itself, and the module development for the mobility is already B and moving now into C phase. So the cell is ready for order, and we secured 5 gigawatt-hours of production capacity. So we are more than ready to deliver the cells, and the modules. Some of these modules that you've seen have, of course, different stages, but one of them is already delivered to a few customers and are being tested and evaluated.
Is there in the pack the BMS is already implemented?
For the mobility module, it is not included BMS, so it's intended to be placed in a pack solution with where the BMS will be added. For the stationary storage, we are of course working with the BMS as well.
Okay, one last question, please. You said you're aiming for similar characteristics like an LTO, but for the price of an LFP. that would be very interested, as we have a client at the moment who has the problem, who is bound to an LTO technology.
Kevin, stop, hold on. Yeah, Kevin, can you directly connect to Jasmine? I've put his LinkedIn link in the chat. Please connect to him directly. Go on a call with him, have a chat with him. We have one question, a couple. Fuel cell in Norway, do you produce in your own factories?
Well, no, we have innovation line in Norway where we have developed up to A sample. And then, of course, moving from A sample to C sample, you need large facilities, you need large production lines, which is quite costly to build up. So the technology is developed here. It's produced, machine-produced cells, but then we moved and outsourced the production to Asia until we get traction commercial-wise and are able to build commercial lines in Europe or Norway.
Okay. We have one other question. Has a cell passed the propagation and internal short circuit test from 𝗕𝗍𝚋 62669, whatever that is? Where were these tests done? What would be the price per kilowatt hour?
I think for all those details, of course, please connect with me. We'll answer all of them. Here are some certifications. So 𝗕𝗍𝚋 62619, yes, it has passed. TÜV has done the tests, so it is more or less ready commercially to be done. So all tests that are part of mentioned certifications in this slide have been done, and we have available reports. For the commercial aspect of the cell, we can of course take those directly. Please get back to me, and we will discuss those deals.
But just it saves the chat, so you have the question in there from Ponchev. We have another question from Hans. Hans, you were quite early. I know that. Please ask directly Jasmine at the chat because of the time, because it's about if he offers the link or stuff like that. Yeah, just please connect directly to Hans. Let's go directly to the next one, and it's about hybrid cell manufacturing from Jan Stefan. Are you there?
Yeah. Kann man mich hören?
Yes, here we go. So, floor is yours. You have 4 minutes.
Thank you very much. Just a second. I need just. Okay. So yeah, thank you very much, Holger. I'm happy to be able to present one of our recent innovations, the hybrid cell manufacturing. For us, the road to a successful battery production in Europe. And what is hybrid cell manufacturing? So this fully disconnects the 3 subparts in the cell manufacturing of electrode manufacturing, cell assembly, and cell activation. And each of the parts now can be done by different companies at different locations and at different timing. All of us, I think, know these headlines, which even become worse at the end of last year, just the keyword Northvolt, and it's going on a little bit, and we are all looking for how can we solve that. So why is this happening? Advanced cell manufacturing is technologically very underestimated and requires many diverse skills from different disciplines, chemistry, machine building, things like that. And you need a very high upfront capex investments, which are needed for large vertical integrated gigafactories. So in the end, the projects get delayed and ultimately fail. So what to do? A new cell manufacturing strategy is urgently needed. And yeah, so we start, and this is a new option that you start at the end with the cell activation in step 1. You source dry cells, which is possible around the world, and you start with the cell activation. And then in the second step, if you want to go further in the supply chain as a company, you source electrodes, and you can scale up to cell assembly, for example. And you can, of course, in the third step, fully integrate the process by starting an electrode production. All in all, you gradually invest by this way and learn while delivering already results, means cells, you produce already cells and can make profit. And by this step-by-step implementation. And what is cell activation? Cell activation starts from a passive assembled cell, which is temporarily sealed to avoid moisture entering into the cell, so-called dry cells. Dry cells can be shipped without any hazards, as they're not activated, don't contain flammable electrolyte, and cannot go in thermal runaway. So cell activation converts this dry cell to an active tested cell ready for use by doing the following steps: the electrolyte filling, the soaking pre-charging, final degassing and sealing, and finally formation, aging, grading, and end-of-line testing. So the whole process. And why PC? PC cell activation technology is enabling hybrid cell manufacturing. Why? Because we have developed so far world unique single-step rapid electrolyte filling, which doesn't require large dry rooms and which is decoupling the cell assembly where the electrolyte filling happens nowadays completely from the cell finishing, which turns into cell activation then. And all processes are done in one fully automated equipment in line. PC has already implemented several reference projects. We have an R&D platform for customer validation, and the solution is hyper-scalable due to modularity and standardization. That is, you see here such a fully integrated line turning around, and on the right side, how you can scale this up. 𝗕PC, in general, we are a partner from R&D to mass production with turnkey solutions for cell testing and cell production. We have several customers in all fields which are covered or related to batteries. We have a strong focus also on automotive customers. For example, we work for BMW or Cellforce Porsche, Daimler Truck, and others, and also for a couple of cell makers. So if you have, for example, Apple AirPods, the cells from Bata inside are running over our machines already for a couple of years. Yeah, thank you very much. And I would appreciate if you are interested in our technology. We have also further informations. If you could contact me either via email or via my mobile phone. I'm happy to hear your questions. Thank you very much.
Okay, thank you very much. Any questions to Stefan?
What about the contamination in each step if you separate the steps? How are they transported?
Yeah, of course you have to. I mean, the cells, the dry cells are going into the cell activation line, and during the proceeding, there is a permanent, how you say, the cells are permanently degassed.
Okay, any other question?
But still, it justifies the effort you have if you shift production to different locations. What is the main reason companies are doing this?
First of all, this is a new option for the companies, and you know, the key thing is that nowadays you use large dry rooms in the cell assembly for the filling, and then after that you have to do the first pre-charge within 2 or 3 hours. So there's a strong time dependency. And with this decoupling, and by doing the rapid single step filling in the cell finishing, and like rapid is really within a few minutes, less than a few minutes, and also with a much lower soaking time, you are very flexible and you can activate your cells at the time and at the place where you need the cells. And this gives a lot of advantages, which I can tell you it was very difficult for me to put all this in 4 minutes. So I'm happy to get your contact and go into further discussions, of course.
Thank you.
I never thought I would make it.
Yes. Just one thing. If you guys want to present yourself in battery innovations in the spotlight, please, yes, put your name up in the link I've already shared, because that's the way to get here. And you're getting, that's the point, you're getting coaching training anyway to coming together with this one, because we make sure that we want to keep it to 4 minutes, and less is more sometimes, because you make yourself interesting. You come as the hottest topic of your company, because majority of people look at your company anyway if you have a hot topic. Okay, and if you have a hot topic, please come to our page and simply put your name in there. Okay, and we're coming now to the last presentation. We always had a lot of people applying, so apologies that we do not take everybody for the session we promised. So we push these people forward to the next session or the session thereafter. So we'll definitely find a slot to make sure everything works. So please be polite with us. So we're coming back to you via email. If you hear from us and you don't answer, you might go off the list. So that's what you have to know, because it's otherwise very time-consuming to really find the people, which is not in the end of the day. Sometimes it's a spam folder, but we simply can't fill it up. So just if you see my name, I will share my link as well. Please contact me directly. If emails got lost, your message got lost, it's because we don't want to have you here. It's because there might be a failure in the email system. So we're coming now to power electronics, and you can use it for really the next generation energy storage. And we have Jens with us, who will talk about it. The floor is yours for 4 minutes, and we have 4 minutes for the answers, questions and answers.
Thanks, Holger. Yeah, ladies and gentlemen, all battery systems need power electronics. But why? Let me show you. What happens when the battery is connected directly to one of these cables? 1, 2, 3, boom. Without the right power electronics, it's a disaster. Battery storage is critical for the energy transition, everyone says. But today's systems, they are inefficient, expensive, and they don't last as long as they should. Our solution changes all that. Let me explain how. We've created a power electronics platform that integrates battery management and the inverter onto a single circuit board, placed directly at the battery cells. What does that mean? It means up to 20% lower costs, up to 90% less energy loss, and up to 50% longer system lifespan. Experts agree on the impact of our innovation. Professor 𝗕𝘁𝘁𝗶𝗵𝗵 from the Karlsruhe Institute of Technology says, our approach can achieve significant efficiency gains and offer a clear advantage. Pretty impressive, right? But the real challenge for companies? Integrating battery storage into their products is hard. Off-the-shelf solutions are too rigid and costly, and in-house expertise is often unavailable. That's where we shine. By equipping each cell with its own power electronics, our solution unlocks a new level of flexibility and scalability. It is highly scalable in current and voltage, currently supporting voltages up to 1,500 volts and currents up to 200 amps. It enables smaller and lighter systems. It is built modular for robustness and easy repairs. And it is safer than any other solution. There simply are no dangerous voltages when powered off. We've created what we call a software-defined battery. This means we can provide nearly any voltage form, direct current, alternating current, or even custom voltage shapes tailored to specific applications. The result is a battery system that's not just flexible and scalable, but also perfectly adaptable to the unique needs of diverse industries. And here's the best part. We make it simply for you. Our licensing model and integration services let you leverage our platform to develop your own storage systems faster, cheaper, and more efficiently. Let's transform energy storage together. Reach out to discover how we can help. Thank you.
Thank you. This was on point. So I share your LinkedIn link directly here in the chat. Any questions to Jens? Please either connect him on LinkedIn or connect to him anyway, if you're interested. But connect to him. But any questions, floor's open. And then just one thing, please contact Jens directly. The first link, the second link is a company link to the company. You can't connect to companies. So.
Oh, okay, sorry. Thanks.
Mentioning it. So. Okay, any questions? Makes it also sense for 48 volts.
Yes, in our view, it makes sense for 48 volts because you can build standardized modules a bit smaller than right now. It's because of the form of the PCB that's taking up less space. And you can put in more cells than usual in one module. This means you have a kind of over-provisioning, and one cell dies, the module still works as before because we can simply skip defective cells. This is one of the big advantages of our technology. How do we isolate the 1500 volts according to electrical safety? That's a question to our specialists. I know they were going to great lengths in isolation testing. The idea is that the cells are connected on demand, step by step. So you have high voltages only on the extreme ends of a battery pack, and between cells, at least in the off state, you have at max the one cell voltage. But if that's a real concern, contact me and I'll get you in touch with the experts. If I understand correctly, one can do battery cyclometry. Can one do this on individual cell level or a full battery? Yeah. That's a good question, and it's again very technical. I would have to get in touch, but right now in testing, we're doing it on cell level because we want to know if there's any differences in the way cells behave, and we're gathering large amounts of data right now. The idea is that the algorithms are then able to decide which state a cell is in, so that we don't have to do the whole data collection but each cell has its own microcontroller. So yeah, specifically each and every cell is monitored all the time. Thank you. Okay.
So there's one. Yeah, go ahead.
Sorry, how the batteries are connected. Does our system replace the connections? Yes, it does. The batteries, the cells are connected by the same PCB where the power electronics is on. So the connection is directly from the PCB to the cell, and the cells are then connected to one another by MOSFETs that form H bridges. So we can selectively switch on and off cells, and we can also bypass them to have lower voltages.
Okay, perfect. There's also in the chat from Hans Konstantin the question to connect regarding the, please, Hans, reach out directly to Jens. I know you're active on LinkedIn. Please connect him directly to have this discussion. So I think we're close to the end. We have a perfect timing again. So everybody, I've seen Enrico on the call. I haven't received feedback on the mail. Please connect me via mail for your presentation, because that got listed on the list for this week. But it got moved to the next one. I don't know if Enrico is still there. So everybody, thank you for being here. I will place my LinkedIn link in the chat as well. Please connect to me if you're interested, how we achieve such big meetings, because it's called the network of network contact. It can be done for everybody, especially for the automotive industry, battery industry. We're quite strong there. Please let me know. And I would love to see you next time. It's on the 12th of February. It's a Wednesday. So mark your calendars. We are streaming directly from the ECP, the European Chemistry Partnering event. If you want to see us live, so we are streaming that directly, but it is an online session, so there's no problem. Join live. You have seen all the links on the ECP. I've shared that before, and I would love to see you again the next time on the 12th of February. And if you're interested, participating yourself in the chat. I've thrown the link in the chat already. I can redo that. So that is the last thing I'm throwing in there. And I wish you all, yes, a happy evening. And greetings here from Zanzibar, because I'm sitting in the middle of Zanzibar, and we had no power outage in the middle. We had no internet outage. I had internet in the middle of the ocean today, which is unusual in Germany. And with this one, this is only a small message to politicians. Please work on the infrastructure, and please work on batteries, because these are needed. It can build futures for people. So thank you, everybody, and see you next time.